Welcome back. This video is part 4 of a 9-part series on completing the square. In this video, we'll discuss a shortcut method for completing the square, and I'll give you a warning about using shortcuts without understanding. And then we'll discuss how to solve for x after completing the square. I suggest that as you watch this video, you take your own notes. Get a pencil and some paper, and let's get started. Let's review the steps for completing the square that we discussed in that last video. Step 1 is to find b and b over 2 and plug them into the perfect square pattern, and find out what we need to add to complete the square. Step 2 is to add that quantity to both sides of the equation to complete the square. And step 3 is to write the left-hand side of the equation as a perfect square. There's a shortcut that allows you to get the same result, but with much less writing. Step 1 is to find b over 2. Step 2 is to write the left-hand side as a perfect square. And step 3 is to add b over 2 squared to the right-hand side. In this example, b is 8 and b over 2 is 4. We write the left-hand side as a perfect square, x plus 4 in parentheses squared, and we add 4 squared to the right-hand side. 4 squared is 16, and 111 plus 16 is 127. Finally, we get x plus 4 in parentheses squared equals 127. The method we discussed in the last video is in the upper left, and the shortcut method is in the lower left. As you can see, there's much less work shown. There are 2 reasons for this. First, the shortcut method doesn't directly refer to the perfect square pattern. And second, the shortcut combines a few of the algebraic steps by jumping directly into the perfect square form. While this shortcut has clear advantages, there can be disadvantages. You should remember that shortcuts in math should require less writing, but not less thought. If you find that a shortcut allows you to do something that you don't understand, then you probably shouldn't be using it. But you should decide what approach to take based on your own situation. I just want to warn you that if all you know is a shortcut, then your knowledge of the subject will be very shallow. The shortcut without understanding is easy to forget, not adaptable, will have no connection to other math, and will not prepare you to learn future math topics. You may find that a shortcut now may put you at a disadvantage in the long run. We're going to move forward using the shortcut, but as we do it, we're going to think through the steps of the longer version. Here's an example using the shortcut method with a negative number. We start with x squared minus 10x equals 11. b is negative 10, and b over 2 is negative 10 over 2, which is negative 5. If we add negative 5 squared to both sides, we will complete the square on the left-hand side, which can then be written as a perfect square x minus 5 in parentheses squared. 5 squared is 25. After combining 11 and 25, we get the final result x minus 5 in parentheses squared equals 36. Next, we'll discuss how to solve for x after completing the square. But before we get to that, we need to discuss how to solve for a squared quantity. If we want to solve for x in the equation x squared equals 11, we have to take the square root of both sides and include the plus or minus symbol on the right-hand side. I'll describe the meaning of this notation in a second. The square root and the square on the left-hand side cancel, and we get x equals plus or minus the square root of 11. If you're not familiar with the plus or minus notation, it means that there are 2 solutions, one that's positive and one that's negative. So the 2 solutions are x equals positive square root of 11 and x equals negative square root of 11. We can check these 2 solutions with the original equation x squared equals 11. Positive square root 11 squared is positive 11. And negative square root of 11 squared is also positive 11. A negative number squared is always positive. So these types of equations always have a positive and negative solution. Here's another example with a perfect square. We have x squared equals 64. We take the square root of both sides and include the plus or minus symbol on the right-hand side. We get the square root of x squared equals plus or minus the square root of 64. 64 is a perfect square and can be written as 8 squared. In the next equation, we have the square root of two perfect squares. The square root and the square cancel out on the left-hand side and on the right-hand side, and we get x equals plus or minus 8. Our solutions then are x equals positive 8 and x equals negative 8. Now let's use those skills to solve for x after completing the square. Let's continue an earlier problem for which we have already completed the square. We started with x squared plus 12x equals 53. And after completing the square, we got x plus 6 in parentheses squared equals 89. We now perform the new steps. We take the square root of both sides and include the plus or minus on the right-hand side. On the left-hand side, the square root and the square cancel. We get x plus 6 equals plus or minus the square root of 89. To solve for x, we can subtract 6 from both sides. Another way of doing the same thing is to think about the positive 6 moving to the other side, but when it gets there, it becomes negative. After doing that, we get x equals plus or minus square root of 89 minus 6. Our two solutions are x equals positive square root 89 minus 6 and x equals negative square root 89 minus 6. It's very common for these solutions to be written with the plus or minus term as the trailing term, which requires switching the order of the terms. So if we reorder the terms by moving the trailing term to the front, we get the more common form x equals negative 6 plus or minus the square root of 89. If your instructor requires you to use this form, then you'll need to take an extra step to reorder the terms, as I've just done. However you write the solutions, the numeric values will be the same. I used my calculator to calculate the values of the two solutions. I got x is approximately equal to 3.434 and negative 15.434. These are only approximate because I rounded the value to 3 places after the decimal. Let's check these values to see if they satisfy the original equation, x squared plus 12x equals 53. When I plugged in both values into the equation, the results were approximately equal to 53. I like doing checks because I can sometimes lose track of the original goal of a problem, especially if it involves a lot of steps. I find that performing a check at the end can help me get reacquainted with the original goal. Let's do an example that involves a negative sign. We did the first half of this problem earlier. We started with x squared minus 10x equals 11. And after completing the square, we got x minus 5 in parentheses squared equals 36. We take the square root of both sides and include a plus or minus on the right-hand side. 36 is a perfect square, which is 6 squared. We have the square root of a perfect square on both sides. The square root and the square cancel on the left-hand side and on the right-hand side. We get x minus 5 equals plus or minus 6. We move the negative 5 to the other side, and when it gets there, it becomes positive. We get x equals plus or minus 6 plus 5. The first solution is x equals positive 6 plus 5, which is 11. And the second solution is x equals negative 6 plus 5, which is negative 1. Let's do an example where the solutions are complex numbers. We start with x squared plus 4x equals negative 10. b equals 4, so b over 2 is 2. We can imagine adding 2 squared to both sides and completing the square on the left-hand side. We get x plus 2 in parentheses squared equals negative 10 plus 2 squared. 2 squared is 4. And negative 10 plus 4 is negative 6. So after completing the square, we get x plus 2 in parentheses squared equals negative 6. We take the square root of both sides and include a plus or minus on the right-hand side. On the right-hand side, we get plus or minus the square root of negative 6. The square root of a negative number is an imaginary number. The square root of negative 1 is lowercase I, which is called the imaginary unit. The square root of -6 is equal to I times the square root of 6. So returning to our equation, we get x plus 2 equals plus or minus I times the square root of 6. We move the 2 to the other side, and when it gets there, it becomes negative. We get x equals plus or minus I times the square root of 6 minus 2. If we reorder the terms by moving the trailing term to the front, we get the solutions x equals -2 plus I times the square root of 6, and x equals -2 minus I times the square root of 6. Numbers that are a mixture of both real and imaginary numbers are called complex numbers. Previously, we said that the solutions to these kinds of problems were the values of x where the graph of the function crosses the x-axis. So what do complex solutions involving imaginary numbers mean? It turns out that complex solutions mean that the function does not cross the x-axis, as you can see on the graph on the right. Now you try. Complete the square and solve for x. Pause the video and try the problems. For the first problem, b is 4, so b over 2 is 2. We add 2 squared to both sides and write the left-hand side as a perfect square. We get x plus 2 in parentheses squared is equal to 1. We take the square root of both sides and include a plus or minus on the right-hand side. Solving for x, we get x equals plus or minus 1 minus 2. The two solutions are -1 and -3. For the second problem, b is -16, so b over 2 is -8. We add -8 squared to both sides and write the left-hand side as a perfect square. We get x minus 8 in parentheses squared equals 101. We take the square root of both sides and include a plus or minus on the right-hand side. We solve for x and get x equals plus or minus the square root of 101 plus 8. If we reorder the terms, we get x equals 8 plus the square root of 101, and x equals 8 minus the square root of 101. That concludes this lesson. If you liked it, then click the like and subscribe buttons below. In the next lesson, we'll discuss completing the square problems that will require us to rearrange the equations and solve cases where the leading coefficient is not equal to 1. See you in the next video.